So we've been working on this here. This is taking a little longer than normal, but that's probably because the note sheets have been a little bit everywhere. So this is the first one we're starting off with, is the set of prime whole numbers. And we're going to write it in set notation. Now, if I wanted to go on and just list out some of the prime numbers, what is the first positive or first whole number that is a prime number? 0 is not prime.
Oh, shoot. Oh, crap. No, my bad.
2 is a prime number. Because for a number to be prime, it has to fit the definition of 1 in itself. The only factors of prime numbers are 1 and itself. So for 2, it's 1 and 2. 1 is not a prime number because the factors of 1 are just 1. It doesn't have a number other than 1, so it is not a prime number. But that's only been in the last 300-400 years, because at certain points in history, 1 was considered prime. But 2 is the first prime number, prime whole number. Then we have 3, 5, 7, 11, 13, 17. Well, that's not all of them. There's more that go on after this, yes? Is there a defined pattern that we have here that we can state for this year? Well, no, they're kind of all sporadic. They get wider apart. Some of them are farther apart. Some of them are closer together. Because, I mean, the distance between 11 and 13 is 2, but the distance between 7 and 11 is 4. It varies. And there is no, as of now, we don't know what the greatest prime number, if there is one, because that is still something they're trying to figure out, is there a prime number, or if we get big enough numbers, is there going to be a point where there is no more prime numbers, or there's no more that exist? But up to this point, we have not been able to definitely prove it. They've gotten to pretty massive numbers, I think 13, 14 digit numbers, finding prime numbers there. If you decide to take the time and found, say, a 26 digit prime number, you could probably let the government know and they will take it. They will pay for it if you find a massive number like that, because a lot of security stuff or codes, especially when they want to keep something secure, they use prime numbers because there's no way to actually factor down or find numbers that go into it to hack it. Because it's only 1 in itself, so you either got to know the number or you don't. So for this here, to write this in set notation, we're going to start off with this. Brace X bar. The set of all real numbers X such that X is a prime whole number. That's it. It's a little anticlimactic, but that's all there is to this one. Any other questions on this here? Are we ready for the next problem? We're going back to the front of this page. Part of the reason I jumped around is, one, I wanted to go over set builder notation first so we kind of have an understanding of it, like we did yesterday. We went over set notation so we know what it is and know what it's talking about. That way, when we look at these here, we can graph them. Y'all have graphed numbers on a number line before. It's just been a while. So when we look at this here, this is saying that the set of all real numbers X, so any number on this line, satisfies this is going to be included. So really, all this is saying is just graph, this inequality. So the two numbers that we need to include, specifically the endpoints, are what? 2 and 5. So we'll put circles at 2 and a circle at 5. Will we leave both of them open? So we'll close 5 because 5 has the equal to. Because the inequality symbol in front of 5 does have the equal to symbol. So we will fill it in. And 2 will be open because it's just less than. 2 is less than x is less than or equal to 5, so 2 is open, 5 is closed. Now we need to shade. Well, where are we going to shade? Between 2 and 5. If x is in the middle, we shade in the middle. Especially if it's one statement and x is in the middle. We're going to be shading in the middle. That's it. Questions on this here? Are we ready for the next one? For all real numbers x, such that x is less than or equal to 0 or x is greater than 4. So again, we have 2 points. We have 0 and we have 4. Now we need to determine which one's filled in, which one's open, or both are open, or both are filled in. So let's look at 0. Will we fill 0 in, or are we going to leave it open? Fill it in, because the inequality says equals. Now we'll stay here, finish this one up. So it says x is what? Less than or, so would we shade to the right or to the left? Left, because left would be less than. Yeah, it would be the less than, and it would go to negative infinity, yes. Now let's look at 4 next. So x is greater than 4, so will we leave it open or fill it in? Leave it open because it's not equal to it. And for this one here, since it says greater than, we're going to shade it to the right. That's it. Hopefully pretty familiar. Now for most, again, I'm going to say most or statements is probably going to go in opposite directions, but that's not always true. Because they could go in the same direction or they could go towards each other. A lot of times they go in opposite directions. Any questions on A or B? Are you ready to see how to do the next one? So let's look at this one here. The set of all real numbers x such that x is less than negative 2 or x is greater than 0. So our 2 key numbers are negative 2 and 0. Which ones do we fill in? Both open, because neither one of them has the equal to part, so they're both going to be open. Which directions do we shade for negative 2? Left. X is less than negative 2, so we want all the values less than negative 2, so we would shade to the left. X is greater than 0, which means we would shade to the and that is it. Questions on any of these here? We feel good with these 3? We're going to look at the last 2. These are the last 2 we'll do together, and then you'll have the rest of the time to work on the assignment. So the first one, for all real numbers x such that negative 6 is less than x is less than or equal to negative 2. Now for the homework, especially with graphing, I know I said you won't graph. This will be the only graphing you'll do. I'm not going to make you graph 2 variable functions or functions themselves. But I don't think this is too overly complicated or too much to it. Because when we graph this, what are the 2 key numbers that we need? Negative 6 and 2. So when you do it on the homework, I'm wanting those 2 key numbers. One thing I will say is do make sure that they are in the correct order. Smaller number on the left, bigger number on the right. Now we're going to put circles at both of these here. Will one of these be closed? -2 because it has the equal sign. So this one would be closed. And the 6 would be? -6 would be open. And now we need to shade. We shade between 6 and 2. -6 and -2. Because when x is in the middle and we have one statement, we shade in the middle. Questions on this here? Any questions on any of this so far? When x is in the middle of the two, we have one x and two symbols. Let's look at number 5. This time we do have two statements, two numbers, 0 and 10. We'll have two circles, one at 0 and one at 10. They're both closed because in both of the statements they are equal. So we'll fill them both in. Do we shade in the middle? Opposite. Because even if we look at both statements individually, x is less than or equal to 0. So we're going to shade to the left because that's where all the numbers less than 0 are going to be. In the other statement, x is greater than or equal to 10. We shade to the right. And that is it. Questions on any of these here? And that is the last thing we're going to do today and with this section. So you do have the rest of the time to work on this assignment. If you do not get it finished, it will be for homework. That's it. So you can go on and get started. If you do have questions, please ask. I'll come around and answer them.